Matlab offers a wide range of built-in functions and toolboxes for various scientific and engineering applications. Code generation in Matlab refers to the process of converting Matlab code into executable code in C or C++ to run on different platforms or embedded systems. This allows Matlab algorithms to be deployed on resource-constrained devices such as microcontrollers or FPGAs, providing real-time processing capabilities. To ensure the reliability of Matlab functions, Mayhem, a symbolic execution and fuzzing product, can be utilized. Symbolic execution explores all possible inputs symbolically, aiding in the identification of potential vulnerabilities and edge cases in the code. Fuzzing involves testing the Matlab function with a large variety of heuristics, which can reveal unexpected bugs or errors that might not be evident during normal testing. Now, for this example, we have this function here, this Matlab function that we'll be using to test using Mayhem. And in this example, there happens to be a bug that's triggered when we send in the characters BUG. Now, in Matlab, this bug is merely an error and doesn't involve any sort of memory leakage issue. But during code generation, this will actually cause an out-of-bounds write. So we have an example repository to demonstrate this. Jumping into the repository, you can see it's called Mayhem Matlab inside of the For All Secure organization on GitHub. We go ahead and go into the function folder. Inside of this folder, you'll see a couple files. Namely, you see this Docker file, this Mayhem file, this Mayhem it, as well as this script here. The Mayhem it.m file is the function we were just looking at. This is the Matlab function. This Mayhem file is our configuration file for our test settings. The Docker file contains the set of instructions to build our image, which containerizes our application when we upload it to Mayhem, as well as this script. And this contains the full set of instructions from start to finish to test our application. So jumping into the script, you can see a couple key points. First off, we use Matlab Coder to convert our Matlab code to C code. This can also be done in the Matlab GUI. We install Mayhem. We compile our code and then upload it to the Mayhem registry, as well as test the code using Mayhem. Inside of our Mayhem file, we can go ahead and see the configuration settings for our tests. This is our image name that we'll be testing. We'll test it for 90 seconds. Our project name is Mayhem Matlab function, and the specific target name is Mayhem it, the name of our function. While we're testing, we're going to do a couple things. We're going to look for some exploitability factors. So things that, these are usually settings that can be set to harden our binary. Regression tests. So every time we find an exploit, we'll save this to a regression test bank. Behavior testing. So we'll look at the total number of behaviors that occurred, and we'll provide a coverage analysis to help us ensure that we had a high enough code coverage to know that we tested our application thoroughly. And finally, there's this command here to test our application. This executes our application via Mayhem. Inside of this Docker file here, there's two things to look at. First, we have a set of instructions that compiles the C code generated by Matlab. And secondly, we have the image with the compiled application under a base image. In this case, we're using Debian 10 Slim as the base. So let's go ahead and run our script. And to do that, we'll just open up a terminal. So we have this terminal window. And so go ahead and run that script. And when it's done, it'll look something like this. At the bottom here, we can go ahead and copy this URL, and this is where our run is shown. This can also be accessed by logging into your Mayhem account and going under the project that it's stored under. So in this case, we have this run 6, and the first thing that we see is these exploitability factors. For our Matlab binary, we didn't enable these, but this is something that you can do to harden your binary. Additionally, we see straight away that there was a defect that was found. 3 of the test cases generated by Mayhem caused crashes. Our test suite size of unique behaviors was 29, and there were 787 unique, total behaviors observed. We can see the defect was found early on, and we can see at the bottom here some metrics of code coverage. So this is the percentage of blocks or memory blocks covered during the run. We have function coverage, which tells us the percentage of functions covered, as well as line coverage, which tells us the total number of source lines of code covered during the run. Now, jumping into the issue, we have this out of bounds write, and we can go ahead and see the specific issue that was found. In this case, we see that the test case that caused the crash was BUG and some trailing characters following that. The standard output was bug here, and this was something we put in our example function. Oftentimes with these type of issues, we'll have no standard out, and they can be quite difficult to find. We provide a backtrace, and inside of the backtrace, you'll see the actual source files as well as lines of code. And this can be integrated with backtrace and Sentry, and this can help you to better visualize what actually occurred during the run. We provide a disassembly as well as the faulting address. So this was the memory address in which the out of bounds write occurred, a register state, the signal number for how the application crashed, as well as a memory mapping. And so with all of this sort of plethora of information, you can use this to debug your application, as well as reproduce the issue that occurred. And this can be used to help ensure that your application is reliable and secure before you put it on hardware. This concludes the demo.
Go to mayhem.security and click Get Started. See for yourself how Mayhem can simplify your application security testing today.